Last time I mentioned that atoms can form bonds to become stable, and remember that's because if they don't have 8 valence electrons, they want to get to 8 valence electrons. So an ionic bond occurs when electrons are transferred. So electrons actually move from one atom to another, and that results in a charged atom called an ion, and those ions, because they have opposite charges, will stick together. So let's take a look at the common compound, sodium chloride, NaCl. Okay, sodium, if you look at the periodic table, sodium is in column 1, it's element numbered 11, which means it has 11 protons in the nucleus, 12 neutrons because it's an isotope, it's 23. Then if we look at that, it's got its first 2 electrons in the first energy level, it's got the next 8 electrons in the second energy level, that gives us 10. We need 11 to balance those protons, so its last electron is actually out here. So if we were to draw the electron dot diagram for sodium, it would look like this, Na with a 1 dot. Okay? Now, that would really, this sodium atom, if it could lose this electron, it would go back to this full shell, which is what this shows, and it would be pretty content to do that. It would be stable then. So what we end up with is we end up with sodium without that electron. It gives that electron away, and because it does that, it now has 11 protons and only 10 electrons, which leaves it with a 1 plus charge. It's got 1 extra positive charge. So this is the electron dot diagram for a sodium ion. Okay, so electrons are transferred, that results in charged atoms, and charged atoms are called ions. And ions can be positive or negative. Usually positive ions are cations, so this is a positive ion, it's a cation. Now, this electron actually has to go somewhere. So this electron ends up coming over to some other place, and a good place for it to go would be chlorine. Because if you look at chlorine, chlorine has the opposite problem as sodium. It's got 17 protons, so 2 electrons in this first energy level, 8 electrons in the next energy level, which gets us to 10, 7 more, which gets us to 17, and that means it's got room for 1 more valence electron here. Okay, so it'll actually take in, okay, so chlorine, if I was going to draw its electron dot diagram, I have 1, 2, 3, 4, 5, 6, 7. I like this method because I don't have to draw in all those energy levels, but remember those other electrons are still there. Okay, so chlorine has its 7 valence electrons in an open spot. So it'll actually take in this extra electron, add it to its last energy level, and become chlorine with 8 valence electrons. But now it's got 1 extra electron. It went from having 17 electrons to 18 electrons, but it still only has 17 protons. So that means it's got a 1 minus charge. It's got 1 more negative charge than positive charge. So this is how an ionic bond forms. An electron transfers from one atom, leaving it positive, to another atom, leaving it negative. And then the opposite charges attract, and these stick together. So this makes sodium chloride. Now, covalent bonds are a little bit different. This shows a covalent bond that forms between hydrogen and oxygen, and this is sharing of electrons. Now, I didn't mention this, but I'm going to go back and say it. Ionic bonds involve metals and nonmetals. Right? You're always going to have a metal and a nonmetal in an ionic bond. Covalent bonds involve only nonmetals. Okay? Because if you're going to share, that means sharing is a selfish thing to do for atoms, because that means they don't want to give anything away, they just want to take. And the metals always want to give away an electron because it's easier to lose 1 or 2 or 3 than gain 5, 6, 7, or 8. Okay? So the sharing of electrons happens with nonmetals, and essentially, when you share an electron, both atoms get to count it. So if we consider, I'm going to start by looking at this. We consider oxygen. Remember, oxygen is element number 8, so it has 8 protons. So it's got 1, 2 electrons in the middle, then or in the first energy level, and then 6 more to get to 8 total. But this has got an open spot and an open spot. So oxygen would really like to get 2 more electrons. And if we draw the electron dot diagram for oxygen, 1, 2, 3, 4, 5, 6, we can see it's got 2 open spots. So it will actually share 2 electrons with something else. Now, water forms this bond with hydrogen. Now remember, hydrogen is special. It's got 1 valence electron, but it's trying to look like helium. It's only trying to fill this first energy level, so it's only trying to get to 2. So these two things see each other, and they're like, wait a minute, let's go hang out together. Because if we do, our energy levels can overlap. And then these 2 electrons Well, hydrogen thinks it has them, so it thinks it has a full energy level, and oxygen thinks it has them, so it thinks it's got both of those. It can form 2 of those bonds with 2 hydrogens, and so it's got 8 valence electrons, and each one of these have 2 valence electrons, and neither one of them actually gained or lost anything. They're just sharing. Okay, so the way we represent this with our valence electrons is we say, okay, hydrogen forms a bond with oxygen and another bond with another hydrogen. And then, when you're done, you should be able to count to the stable configuration for everything. Oxygen is stable with 8, so I have 2, 4, and then this line represents 2 electrons being shared, so 6, 8. And since they're shared, we get to count them with both. So this hydrogen has 2, which is stable for hydrogen. This hydrogen has 2, which is stable for hydrogen. Okay. Now, this is called a molecule. Anytime you have covalent bonds forming, you have a thing called a molecule. There are some molecules that are not compounds. Water is a compound because it has hydrogen and oxygen. It has 2 different elements. But H2, because if we have 2 hydrogen atoms, they're going to look at each other and be like, hey, we could share those and we could be stable. So we have H. Okay, this is not a compound. This is H2. It's a molecule because there's 2 atoms stuck together, but it's not a compound because they're not different elements. So in order for a compound to form, they have to be different elements. Now there are several atoms that only come in pairs in nature. We don't see them by themselves. That's bromine, it'll be Br2, iodine, that'll be I2, nitrogen, N2, chlorine, Cl2, hydrogen, H2, oxygen, O2, and fluorine, F2. That's Brinkelhoff if you're following along. These are called diatomic molecules, and they come in pairs. You never find them alone. And if you look at those, like nitrogen has 5 valence electrons. It's in group 5 on the periodic table. That means it wants 1, 2, 3 electrons in order to become stable. So if I had 2 nitrogens, I'm going to put my valence electrons around it, and they can go, hey, look, we could share this one, and then we'd have those 2 taken care of. We could share this one and have those 2 taken care of, and we could share this one and have those 2 taken care of. And we get nitrogen atoms with what's called a triple bond between them. And so that's a covalent bond that forms between 2 similar or 2 identical elements, and it's a molecule, but it's not a compound. The rest of these all do similar things. Fluorine forms a bond between it and another fluorine, and then oxygen does that. It'll be a double bond with oxygen because it's got those 2 electrons to share. Chlorine will be singles. Bromine will be a single. Okay. So bonding is just a way for atoms to become stable.